Hi everyone, Assalamualaikum. In this video, we will discuss mean value theorem for differentiation, which is the last topic under application of differentiation, right? The mean value theorem for differentiation said that if fx is continuous on a closed interval ab and differentiable on the open interval ab, then there exists a number c in open interval AB such that f prime c equals to fb minus fa over b minus a. Alright? The value of c here must be between a and b. Right? Now, we look at example 1 from the previous semester papers. The mean value theorem for differentiation states that if fx is continuous on a closed interval ab and differentiable on the open interval ab, then there exists a number c in ab such that f prime c equals to fb minus fa over b minus a. If fx equals to x plus 1 over x, find the value of c in the interval half 2. Right? Alright, when we solve this question, okay, after we find the value of c, we will get c between interval half 2. Okay, if we get c between half and 2, means that we get the correct answer. Okay, but if we get c outside this interval, okay, means we get the wrong answer. Alright? Alright, to solve or to find the value of c, we can use this formula. Okay, so from this formula, f prime c equals to fb minus fa over b minus a. Right? From this formula, first we need to find a, b, fa and fb. Okay, so step 1, identify the values of a, b and fa, fb. Okay, and then from this formula also, we need to find f prime c. So the second step, we need to find f prime c. Okay, to find f prime c, first we need to find f prime x. Right? Right. So to find the values of a, b, okay, a equals to the begin of interval. Okay, we can compare here. Okay, so our a equals to half. Okay, b equals to the end of interval. We can compare here. Okay, so our b equals to 2. Okay, after we find a and b, okay, we can find b minus a. Alright, b equals to 2, a equals to half. So when we solve 2 minus half, so we get 3 over 2. Okay, alright, and then we need to find fa and fb. Okay, to find fa and fb, we can refer from fx. Okay, fx from the given question here equals to x plus 1 over x. Okay, and then from here we can find fa. Okay, our a equals to half, means we need to find f half. Okay, so we just replace half into whatever x here, into fx here. Okay, so after we replace and we solve, so we get fa or f half equals to 3. Right? Then we need to find fb. Okay, fb equals to, we replace b equals to 2. Okay, and then equals to, we replace 2 into whatever x in fx. Okay, so after we simplify, after we solve, so we get fb equals to 3 over 2. Okay, after we find fa and fb, we can solve fb minus fa. Alright, fb equals to 3 over 2 minus fa equals to 3. Okay, then after we solve, so we get FB minus FA equals to negative 3 over 2, right? So now we done find the right hand side function, okay? Or the value of the right hand side. Then we can find f prime c, okay? As I said before, to find f prime c, we need to find f prime x first, okay? To find f prime x, we need to differentiate from fx, okay? Alright, from this function, okay, we have single denominator here, so we can separate, okay? We separate, so we get x over x plus 1 over x. Then we can simplify x over x, we get 1. And then 1 over x here, we can write x to the power of negative 1. Alright, why we need to change 1 over x to the power of x? Change 1 over x to the power of negative 1. Okay, because we can differentiate easily. Alright? Right, from here, when we differentiate fx, we get f prime x. And then we differentiate 1 equals to 0. No need to write. And then we differentiate x to the power of negative 1 using power rule. So we move negative 1 to the front here. So we get negative. And then x. And then negative 1 minus 1. So we get negative 2 here. Okay. Then we can move down x to the power of negative 2. Using the properties of indices, so we get negative 1 over x squared. Alright. After we find f prime x, then we can find f prime c. Okay. And before that, to find f prime x, we also can use quotient rule because this is division function. Okay. And we have numerator in variable x and denominator in variable x. So we can differentiate using quotient rule. Okay. But we choose the easiest method. Okay. Alright. So to find f prime c, we just replace c. We just replace x by c here. Okay. So we get negative 1 over c squared. Alright, so now we done find f prime c, we done find fb minus fa, and then we done find b minus a. Okay, then we can continue with step 3 to find the value of c. Alright, from the previous slide, we find b minus a equals to 3 over 2. FB minus FA equals to negative 3 over 2 from step 1. Okay, and then from step 2, we done find f prime c, which is equals to negative 1 over c squared. Okay, then we can continue with step 3. Okay, use f prime c equals to fb minus fa over b minus a to find the value of c. Alright. Right, so from here, we can replace f prime c equals to negative 1 over c squared. And then equals to, we replace fb minus fa equals to negative 3 over 2. Okay, so we put here. Okay, and then over, we replace b minus a. Okay, equals to 3 over 2. So we put here. Okay, and after that, we have same numerator and denominator, which is 3 over 2. So after we simplify, so we have negative here, so we get negative 1, okay, for right hand side. Okay, and then we can cross multiply. So after we cross multiply, so we get c squared equals to positive 1. Okay, and then c equals to, we move square to right hand side, so we get square root. Okay, and when we have square root, we can put plus minus here. Okay, c equals to plus minus square root of 1. And square root of 1 equals to positive 1. So we check the value of C here, whether it is in interval half 2. Okay, so C equals to 1. Okay, C, before that C must be between half and 2. So now our C equals to 1. Okay, so C equals to 1 valid in interval half 2. Right? But from C here, we also have negative value. Okay, C equals to negative 1. We compare from here. Okay, C equals to negative 1 is not between half and 2. So we can write C equals to negative 1, invalid in interval half 2. Right? So this is the final answer. Okay. Coming up next, more examples for mean value theorem for differentiation. Okay. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.